Hello and good morning. Welcome to day number 3 of World Dairy Expo, and I have the pleasure of kicking off this day's Knowledge Nook sessions. My name is Mark Doornink. I'm with VES-Artex, where I'm the VP of Product Management. At VES-Artex, we innovate and implement intelligent barn systems that optimize animal welfare and drive operational efficiency for dairy farms around the world. A little bit about myself. I've lived in Wisconsin my entire life and worked in the industry. I've been with VES-Artex for almost 2 years now. Prior to that, I worked for an agricultural software company in the areas of herd and feed management for about 20 years. Prior to that, I did nutrition work, artificial insemination, and was a herd manager for our family dairy farm. And on the family dairy farm, I started my love for technology in the industry, but really it started very selfishly because I wanted to implement something that I could have my cow information on the palm of my hand so that my feet didn't hurt so much at the end of the day from walking all around. So it was really a selfish motivation, and it started with a Palm Pilot. So anybody that knows what a Palm Pilot is, I'm dating myself in the 90s, but certainly technology has advanced past then. But it fueled my passion for how I can successfully implement technology or help implement technology on dairy farms that really help drive efficiencies in operations. So for today, we will talk about the digital transformation that we see coming to the back of the barn. And I'll explain what back of the barn is in a moment. And how that digital transformation will be powered by DairyBOS. And what do we see on the horizon from the digital and technology that's coming to us? And I'll finish with simply just some questions, answers, and maybe a brief demo if we have time. So if we think about how has technology already changed, or how will it continue to transform our industry? Think of just how we do our shopping now in 2021. With Amazon, where we can have things virtually the very next day. How will that technology continue to shape our industry? Think about what has changed in the last 20 or 30 years, even the last 10 years within our dairy industry. Think about in the early 2000s, we hoped we had internet, and it was dial-up, and now we have internet on palm of our hand in our smartphone. So for probably the last 100 years, not a lot really has changed. Now, this isn't a photo of family or anything, but just showing there's a lot of things that went on in the barn that look old that we're still doing in some forms today. And over the last, say, 20 or 30 years, all we've really done is hung components in barns, say fans, lighting, ventilation, cooling, that really haven't had a direct correlation or relationship to the animal, or even how the animal could control that. Think about the barns are not being responsive to the animal's needs. If it was too cold in here, we might get up and ask or turn down up or down the thermostat. But can the animals do that themselves in the back of the barn? And the animal herself has changed a lot. Since about 2007, 2008, when genomics came out, the trajectory of genetic progress has steeply increased, but our barns have not really changed since that time. So we're producing this, creating this high-performance athlete, if you will, that is in an environment that hasn't kept up to what the needs are. So I call it putting a smart animal perhaps in a dumb environment. The picture on the left here, that barn is a barn I visited in Serbia. There's 100 cows in that barn. Not a fan in sight, not very much feed in sight, and they had 1,000 cows, so they had 10 barns just like that, all tie stall barns. And so certainly the facilities are not meeting the needs and the performance of that athlete or the animal we're putting in there. So another way to think about it is, would we put Michael Phelps in the kiddie pool? Of course not, but it's a pool, it holds water, so therefore he should be fine in that. But it's a ridiculous example when I make it that way, but yet we put the animals in the same situation. Advances in the last 5 years in technology have really allowed us to do what was impossible before. And on the farms, we need to use that technology to narrow the variation of that bell-shaped curve from the environment, from those environmental factors. So how much variation in animal productivity comes from the environment? I'm going to say nearly 100%. The genomics or genetics of the animal doesn't change after conception. So everything we can do that influence that animal, there are a few exceptions, we won't get into some of those, but it's nearly 100% is going to come from the environment. And those physiological needs of the animal are changing every day. Think about all the things that change, whether it's weather, feed, you name it. So what are the physiological needs of our dairy animal? One way I think about it is talking about Maslow's hierarchy of physiological needs, or Maslow's hierarchy of needs. We're talking about the base level physiological needs for that animal. Maybe we get into a little bit of the safety there. So I call it Maslow's hierarchy for cow. So what does the cow need in her environment? Air. We all need air, but she needs air as well. Great feed every day. Water to drink. A safe place to shelter that's warm and provides rest. Not a lot different than what we need, but we think about it in terms of cow. Maslow's hierarchy for cow. So if we think about it and put the cow in the center of our attention, everything we do, every dollar we spend, every minute that we spend should be to optimize the animal's environment. And we know when we do that, and we've known for centuries, the caretakers of animals have known for centuries, by taking very good care of their animals, they've been able to feed their family, feed their village, or feed the world. Because the results are longevity, health, efficiencies, and productivity and profitability. So if we continue to keep the animal in the center of our environment, or center of our focus, I should say, let's talk about the first ring of things that go out from there. It's Maslow's hierarchy, the basic needs of water, air, feed, that environment, the shelter, the barn. They touch the cow every single day. The next orbit out are all the systems that we put in barns that try to affect those things. So it could be the things that happen in the front of the barn. By front of barn, say the milking parlor and all the operations, the utility room that create the environment around that cow. But also we start moving into herd and feed management. We get into the back barn with manure operations, systems around dairy steel, so the stalls that we create, the environment with the gates and the pens, lighting, of course ventilation. All those are systems that need to affect what happens to that cow at the middle. And the people. Now we put people in there. People have to run the systems. So obviously we have the herd and feed, the herd managers and the owners and the daily workers on the farm, feed suppliers, but then companies like VES-Artex and the equipment providers, genetic providers, of course, and then things off the farm downstream. What are they all seeking? What are all of these people seeking? Productivity, efficiency. We call it business intelligence. I would say, let's call it dairy intelligence. How can the farm be run more profitably? But all of those things, look how many orbits we are away from what's most important, and that's the cow in the middle. So the cow is our center of focus. So for VES, we call it DairyBOS, Barn Operating System, DairyBOS. Everything that we do, everything that touches the animal should be carefully controlled. Think about measuring all the inputs and comparing them to all the outputs. For DairyBOS, we'll go wide across the farm, so we'll have a lot of data sources, a lot of inputs from sensors and devices. And as we started developing DairyBOS, we also said that we could go deep into our VES-Artex process to drive customer satisfaction and drive ultimately value for the dairy producer. So I'll go through some of the components here. I'll list them out briefly to start, and then I'll talk about each one individually. So we have smart connected devices. You can guess what some of those are. Maybe a few are surprises. We put sensors and probes in the barn, the data sources. We have a lot of existing on-farm operational systems. We need connectivity to move the data. We apply some computational fluid dynamics, or CFD, to what we do in precisely engineered dairy barns, and we harness the power of the cloud. Let's start talking about smart connected devices. In this case, we're talking about a smart motor. This is an example. Turntide is our parent company, and they make a smart motor. It's a switched reluctant motor. It's not an induction motor, which has been around for, say, over 100 years. This is a different type of motor that up until 5 or 10 years ago was unavailable to applications such as dairy barns. It was used in nuclear reactors, mining, those types of things where it had to just work and work all the time. It wasn't until we got the internet and computation or faster computer speeds in a small enough space that we could put it out for dairy barns. So that motor provides continuous feedback. It's a smart motor. So instead of just turning on, it'll tell you how hard it's running, how much current it's using, what RPMs are actually versus what was supposed to be run. So there's all kinds of feedback that it gets, and that means it's going to be more efficient. And it's also more efficient that we don't use rare earth metals, which keeps costs down and mining down. It's made of steel and copper. Still mining, but much more common than permanent magnets. Next, we connect that to the cloud. Again, through our parent company, Turntide, we have different levels. So we connect our machines. We'll talk about the motor there at the bottom. And then through edge technology, moving that to the cloud, and then providing cloud insight. Our parent company is in many other verticals, so just agriculture is one of their areas. They're also in buildings and building management and helping those become more efficient with rooftop air conditioning units, and also in transportation. Think of autonomous vehicles in some of the things there. We're working on those projects. A lot of people in our company, agriculture is one of those verticals, and that's why we're here today. So smart connected devices, I mentioned the motor. The motor then connects to an edge router, or what we call a supervisor. Very simple to wire up. We put those in the barns, and those help run wirelessly to a motor control. So the motor control changes the speed of the fan up and down exactly according to what's needed. And we do that wirelessly. So those smart connected devices go into a panel such as this. So I took a picture of one in an actual barn. There's a lot of guts and things in there. I don't know what all of them do, but they're certainly important. But the important part for me is that I can put it in the environment where it matters. So this is in a freestall barn in the Midwest. And you can see one of our fans there in the background, and it's communicating wirelessly to that fan. So it's telling that fan what to do, how to run, based upon the inputs of the environment, weather, and how it's programmed to run. Those smart connected devices we put in the barns, like every star on this screen is one of those panels. So we can put them exactly where they're needed and all around the barn. So these are two facilities for about 3,000, 4,000 animals. And we can put them around to run curtains, lights, ventilation, of course, exhaust fans, and soaking. Attached to that, we put probes. Some of these probes are pretty simple. Temperature and humidity probes are nothing new. They've been available for quite some time. This is an example of one. We also are doing things with static pressure and electricity, so I'll bring them all up. So static pressure, knowing how hard does that fan have to work to pull the air through or out of the building, how much velocity is being created in the building, and then in the bottom right side is a CT or a current transducer. How much, and this is just an example one, there's the ones that we put in don't look this nice because they're in a box and not made for show, but just understand it measures the electricity that flows through the cable by just surrounding it. So how much current are we spending? And then lastly, we've been doing a lot of work with gases. How much ammonia is in a calf barn? We'll get into some of those examples later, but besides ammonia, we're starting to work to see what other methane, hydrogen sulfide, oxygen, carbon dioxide, what other gases are in the barn that we could be looking at. I talked about data sources before. We're starting to work with companies such as Catalyze. Catalyze is a camera vision AI company that measures lameness of dairy cattle by just looking at how they walk in front of the camera. But not limited to them, we also work with companies that where the accelerometers, like Allflex, for example, but also the other ones where can the animal actually start telling us what the environment's like and how the environment should be operated. And then all the other sources on the on-farm, going back to my previous 20 years working with all these companies, they're all great companies. It's by far not an exclusive list. We want to include everybody, work with everybody, just putting the most common examples here on the screen. So that was on-farm data sources. What about off-farm data sources? We need to be able to grab the information that affects us coming in, and weather is a big one. I used to always say weather is kind of boring. I never paid attention to the weather until I started tying it a lot more closely to how the internal environment of the barn and the external environment were related. So we bring in a lot of data sources through the internet. We don't need to use local weather stations, but we use the latitude and longitude of the farm. So very specifically, we connect that with National Weather Service, actual satellite imagery, and others to create what actually happens or will happen at the farm. We bring in things from the Chicago Mercantile Exchange. So right now we're just the United States. So the Chicago Board of Trade and the NYMEX, we bring in that information to tie that production into what's actually happening in the barn. And utilities. We started with electricity. We said our motor is efficient. And the dairyman I went and talked to said, well, that's great, but I have 25% of my electricity comes from my fans. What about the other 75? All right. And he said, what about water? Can you help me with water? Can we understand how much water comes in and out of my facility? So we're working on those things too. So utilities, water, a big one. And then all the milk processing downstream. This is just a screenshot of the common ones that I have, but certainly in the United States we have several hundred to work with. We'll start with the first ones first, Land O'Lakes, DFA, some of the other ones that are on our clients' dairies. So we also have existing on-farm systems. So a lot of times I'm asked, well, in order to have DairyBOS, do I have to get your new stuff? And no. We want to be able to work because it's not realistic to say we're going to go to a dairy farm and rip out all the fans. Say, oh yeah, buy our fans, even though you just bought those 2 years ago. They work fine, but just throw them away because ours are better. That's not realistic. So we want to work with all the existing systems that are on the farm, fans or otherwise, as I mentioned, but also the environmental devices we mentioned, light dimming and light circuits, high pressure fog, soaking zones, we work with those. Curtains and shutters and inlets, and all the ways that we let air into the barn, and manure. We go to see scrapers, we see flush valves, and it's these islands of information that here's another PLC that runs this system that doesn't know that another PLC is 10 feet away running a different system. It's crazy. The back of the barn is going to be digitally transformed together. And then also the utility room. Something simple as vacuum levels. Air pressures or vacuum levels, so for cooling of milk and harvesting of milk. So things coming from the back room, and again, I'll emphasize, does not need to be all VES-Artex equipment. A lot of the equipment exists, and we can integrate that. Connectivity, an interesting area out on dairy farms. Many of you know that. We put in some simple devices. We have a very skilled staff at helping our installers and our dealers do this. But just putting in some simple wireless access points. I know NEDAP would work with a lot in those areas as well and understands the struggles and the benefits from doing those things. But not hard to do, but we can put those in wherever we need them and create the connectivity through that barn for all the systems. I mentioned CFD, or computational fluid dynamics. We very scientifically engineer our barns, know exactly how the air flows. Sometimes all the science and math doesn't matter, and we need to go out and we send out our veterinarians and say, let's run a smoke machine in this barn and actually understand where the air goes. The smoke doesn't know that it's supposed to follow what I think. It follows what it does by just normal math, or normal airflow. So understanding how the smoke versus the CFD work together. Another example that we use is this is a test chamber. This test chamber is probably only about 2 by 2 by 8, but we are building one here in our headquarters in Chippewa Falls that will handle a fan up to 100 inches in diameter. It will be the biggest in North America, maybe the biggest for agriculture in the world. And that allows us to test our fans, understand exactly what they do, how do we optimize them, what happens when conditions change, and how can we make the system respond to that without having the dairyman or the dairy manager make that decision. And then lastly, we'll talk about the power of the cloud. Maybe 5 years ago, they said, they think the cloud's really here. Yeah, we use it every day. So harnessing the storage and the computational capacity of the internet, or the cloud, or Amazon Web Services, AWS, has really helped a lot of industries move forward very quickly and use that knowledge. So let me explain a little bit about DairyBOS. I've talked about the components, but how does it all fit together? So we created a cloud instance of DairyBOS. So you log in through your smart device, and it connects down to what we call an intelligent barn. Intelligent barn has that back of barn systems, and then other IoT devices and sensors, as well as then the equipment that's already there. So it sounds pretty simple. But then we also are going to connect it with what we're calling intelligent farm. That's where we add in the wearables that say NEDAP makes, or the herd and feed management, the cow level information, and we bring that together. Think of it that if the cow is in heat stress, we know that, or the pen of cows is in heat stress, can the system say, they're still in heat stress, it may feel like 60 degrees outside, but their internal temperature is telling me I need to put the fans on longer and let the fans run according to the cow's needs. That's an intelligent farm. As I mentioned, we connect that with the other sources from the internet, such as the weather, milk data, and of course futures and markets. So we keep that animal in the center of the environment that we're looking at. I put all those systems around there in another graphic, and use the IoT and the connected dairy to bring that information together, what we say really for the first time in that back of the barn. Front of the barn has had a lot of technology, but the back of the barn is a little bit scattered. The animal success coming through the engineering of the systems and the design of DairyBOS, bringing in the IoT, Internet of Things of the barn, and hopefully where we want to get to is a tangible sustainability metric. At the end of the day, a lot of the farms say, I record everything in spreadsheets, I have all this information, I fill out the survey and I have to go, yeah, I think we did good. I think we did good? And they're honest in that. No, it has to be better than that. It has to be able to say, hey, we scored a 4.3. It's not perfect, but we're getting better. Our goal is to be to 4.5 by next summer. So we can create that. That's where we want to go with that with DairyBOS. So I'll talk a little bit about what have we learned so far. We're about almost a year in on DairyBOS being released. So I'm going to share with you just a few screenshots of what we have going on. So these are, I mentioned a smart motor. So these are just two different screenshots of smart motors of different exhaust groups. They may be running at 100%, they may be running at 80%, and there's different information here. A lot of times we say, well, the fans are running at a certain speed. What happens when there's a 20 mile an hour headwind against that fan? Is it really running at the speed you want? The answer is no. We know that. The smart motor will actually increase the speed to get to what the requested speed is based upon the pressure against it or with it. We look at running hours, so we're getting into the maintenance of things. This is just an example. We know how much power is being used over that time period. Again, starting to measure what we're spending. This is an interesting one. I mentioned ammonia. So we put ammonia sensors, started putting in calf barns. First time we put it, where did we put it? Right up here, because we had to drive the equipment underneath. Guess where the baby calf lives? Right down here. So we move our sensors down and we started getting a lot of information. Seems like common sense, but you mount things where they're easy sometimes because that's where the electrician or person put them. So you notice a little cyclical pattern here, a spike and then a drop and a spike and a drop. So the way we learn is we go out and ask our farm, dairy owner, dairy manager, what's going on here? He goes, looks at that, the manager goes, well, I put new bedding in every third day. Put bedding every third day, and the cutoff line here, if I can get this, here's about 5 parts per million, right about in here. So we're getting at that borderline. So they made some changes, said maybe we should bed every other day, but just use less bedding to try to keep ammonia levels a little lower. And then we can see when they cleaned out, of course, ammonia level goes high, and then it drops back down and starts coming back up. So again, applying what we see with the sensors into real life and real tangible activities on the farm. Another interesting one here, so I put a freezing line. Ventilation in the summer is super important, but probably in our region in the Midwest where I live, we'll say in cold climates, equally as important is what's going on in the winter. What can we do with ammonia levels? You can see here, ammonia levels are going up and down. They're in, the average temperature is in purple and the ammonia levels in the green. And what happened is you can see the temperature got cool enough that the fans started kicking in and dropped our ammonia levels back down. So we had some mismatch of how we thought we were ventilating versus what we should be ventilating. We helped them make changes based upon that to do things better. Other simple things, looking at temperature and humidity. A lot of people do not understand how temperature and humidity roll through a barn, but just being able to keep an eye on that, and then actually just send an alert out to the farm or the dairy manager and say, how are we doing? Hey, you might want to go check the humidity. I was going to one of our farms that put our system in as a test herd. On the way there, I got a humidity alert. I walked in the barn and I said, whew, it's warm, it is humid in here. Well, turns out they're doing some maintenance on the barn. All the doors are open and the exhaust fans are sucking the air in one side and out the other at one end, and no air was flowing through the facility. So it was right, but those things were going on. Dairyman knew about it in that case, of course, but temperature and humidity over time. Remember, we don't put HVAC into dairy barns. So if it's 90 degrees outside, it's probably 90 degrees inside or worse. So one of our simple goals of ventilation is to keep the outdoor temperature or the indoor temperature as close to the outdoor temperature as we can by moving a lot of air. Cows are little BTU units running around, like 5,000 or 6,000 BTUs all through this barn. They're putting out a lot of heat. So we're able to verify, is our ventilation strategy working the way we want? And it's a boring graph when the lines go together, but in this case, it's working very well. We're keeping the temperature as best we can in the barn to match what's going on outside. And then lastly, I'll talk about some of what we do with weather. These are wind roses. So we load in, we can do historical weather data, and we can also load in and keep track of what's going on currently. These are two different locations, site number 1 and site number 2. And this is the direction in which the wind flows or blows. If it's a little small in the back, this is from May to September of last year. And where did the wind come from predominantly at site number 1 versus site number 2? There's a difference there if you look from where the wind comes out of the east or not, out of the south, and a little bit more out of the north. Different weather. The barns are facing the same direction. Dairyman said, I've done this before, I'm going to put the same solution in each barn. We need to look at what the weather is telling us and how we may have to change what's going on in the barn. So some early things in which we've learned over time. Yeah, and that's what I have. So just a glimpse of where we're at, what we've learned, what we're doing. I've got a little bit of time here at the end for questions if anybody has any. All right. Well, our booth is just in the main exhibit hall towards the front corner, closest to us here. We have a whole staff there and more on DairyBOS if you want to come check us out. You can also check out our website, Facebook page, and all of our social media. So thanks for attending, and have a good day.